Okay, so sorry about this. I've had some technical issues here getting this stream up and running tonight. Oh, man. What is chewing up all of this data? Okay. Really? Okay, we are live. Okay. I'm confident that we are now live. Let me make sure that I can see it. Okay. There we go. Okay. Hello. Alrighty. So, exponential functions. Oh, I see. This is silly. This. Since they have the same base. Right? Different bases. So this can just be set equal to 5 squared. And then that's, okay, I got it there. That's easy. Now let's look at one where the bases are different. So here we would take the log of both sides. So it would be 3x times the log of 2 equals the log of 10. And so 3x would equal, I think that's how you do it. Yeah. 3x log 2 equals x log, wait. Okay, so So 3x log 2 equals x 3 log 2. I think this is a weird one. Okay, let's look at this one. So here it's 1 minus x ln 7, 3x plus 1 ln 4. Okay. Okay, so ln of 7 minus x ln of 7. Oh, it's like we distribute multiply. And then ln 7 minus ln 4, ln 7 minus ln 4. Pull the x out. So then this is just what it is. That's cool. Oh, this would be a fun one. All right, so let me go back. Let's go to the practice problems. So let's look at these. So we are going to, ladies and gentlemen, we are going to solve some exponential functions. And the first one, right here, number 1. Whoa, what was that screen flicker? The first one is 6 to the 2x equals 6 to the 1 minus 3x. So 6 to the 2x equals 6 to the 1 minus 3x. Okay, so here's the deal. What we're going to do is we're going to write 2x, and then we'll write natural log of 6 equals 1 minus 3x times the natural log of 6. And the beautiful thing here is when I divide both sides, okay, if I divide everything by ln of 6, okay, what I get is 2x times the ln of 6 over the ln of 6 equals 1 minus 3x times the ln of 6 over the ln of 6. Well, these cancel out, okay? So all I'm left with is 2x equals 1 minus 3x. And we can solve for x now. We'll just add 3x to both sides. And I'll have 5x equals 1. So divide both sides by 5. And x equals 1/5. That's so cool. Let's go check and see if we were right. X equals 1/5. Wonderful. Okay, so here's the next problem. Well, I'll just write it. Five raised to the 1 minus x equals 25. Okay, so this is number 2. 5 raised to the 1 minus x equals 25. Now, here's something we should make a note of, all right? We have here a 5, all right? And over here on the right side, we have something that could be broken down into 5 times 5 or 5 squared. So I'm going to rewrite the right side like this. So 5 to the 1 minus x equals 5 squared. Now, when these bases are the same like this, we can just drop them entirely and set 1 minus x equal to 2. The reason we can do that is because what we're really doing is we're saying 1 minus x times ln of 5 equals 2 times ln of 5. And when we divide both sides by ln of 5, you see it cancels itself out. So rather than writing all of this and then showing that cancellation, what we do is we just remember that if the bases are the same, we set the exponents equal to one another. Okay, so then it's just a matter of minus 1 on both sides. So negative x equals 1. Therefore, okay, negative x equals 1. Therefore, x equals 1. Negative 1. Which I think is the answer. Let's see. X equals negative 1. We're right. Let's go to the next problem. Okay, so in this problem, we have 8. Ooh, this is interesting. I like this problem. I am a big fan of this problem right here. So these are exponential functions, ladies and gentlemen, if you're just joining the live stream. Let me see what's going on with Discord. Let me see. I'll get my audio working. Deafen, mute, user settings, voice and video. Let's check. And then output device. Yeah, this is looking good. Oh, now I hear myself. Okay, so I guess we have some people on Discord now. Let me turn this down. Can you hear me on Discord? Oh, there's only one person on the call. I got you. All right. Okay. So we're going to solve this problem. 8x squared equals 8 to the 3x plus 10. This is going to be a fun one. So 8x squared so this is going to be number 3. And what we're given is 8x squared. Wow. Equals 8 to the 3x plus 10. So here's the thing. Because the bases are the same, what I can do is just set the exponents equal to one another. Okay, so I'm going to set the pinks equal to one another. X squared equals 3x plus 10. Oh, I love this problem so much. This is my new favorite problem. Where's Kobe? Okay, we got to add Kobe to the call. I don't know how to add him. I don't know what I'm doing. Oh, you are on the call. Hey, bud, what's up? Oh, good. I didn't know what I was. I don't know how to use Discord, ladies and gentlemen, so I apologize. Oh, no. You know what? Was it magnetized to something? Hang on a second. Let me turn down the music. No, I don't think anything bad. Okay, I knew something silly happened. Okay, tell me what happened.
So pretty much when we were leaving the Saturday tutorials, I Okay, I just got it. Okay, so what happened is I was in a rush to leave.
Right.
So my pins were scattered all across your desk, and I wasn't really organized with them. And I just started randomly grabbing them, and I wasn't.
No worries.
Yet I accidentally picked up yours on accident. It was
No worries.
little iPad thing.
Yep, I'm glad. You know what? I'm glad you have it, sir. I was just concerned that it got lost, not that it got stolen. So, I'm glad you have it.
Okay, I'm just gonna return it to you Monday.
Sounds good, bro. Sounds like you got to go.
Yeah. So
Well, thanks for joining.
Yeah, I'll still watch the stream. I just won't be in the call.
Gotcha. Bye. Okay, so I'm so glad Kobe's on. He's a cool dude. All right, let me turn this music back up a little bit. Oh, okay, cool. So I want to make sure everybody understands how I got to this point in this problem. Let me do it again, okay? So we have 8x squared equals 3x plus 10. Okay? Now, the thing about exponentials is when you have a number raised to an exponent, as long as that number is the same on both sides of the equal signs, all you have to do is set the exponents themselves equal to one another. So what that means is, and it's actually best if you don't think about it too much, okay? Just set these exponents equal to one another, and you have x squared equals 3x plus 10. And basically the 8's just go away, okay? And the exponents, the exponents come down, and the 8's cancel each other out, right? And I'll explain why that happens later, but now we have an opportunity. Do you see it's going to be a quadratic equation, which is so cool. So I'm going to do 2 steps here. I'm going to subtract 3x minus 10 from both sides, which will cancel that whole expression out. It's a little bit more of an advanced move. Yeah. Oh, okay. Okay, so okay. Hang on a second. Let me try to do something about. I remember Jasmine telling me something about how I can turn down or boost audio from certain people. Let's see. Yes. Okay, now say something. Wait, what did I do? Just mute him completely? Yeah, I turned his volume up.
There.
Gotcha.
Oh.
Oh, cool. Okay. All right. All right. So here's what we're gonna do. I'm gonna start this problem over, okay? Because I want you to see this.
Oh, Jasmine's here. Hey, Jasmine.
Yeah. Hang on, I gotta raise Jasmine's volume. There. Awesome. Okay, so here's the problem. We have 8 raised to the power of x squared equals 8 raised to the power of 3x plus 10. And let that buffering catch up, and then you'll see it. And while that's happening, I'm going to try to turn down the volume.
So 8. Okay, what was the first power for the first state?
Okay. You'll see it. You see it on the screen now?
Oh, sorry. That's just my parents and my brother arguing.
Oh, I cannot hear anything. Okay. So wait for the stream is going really slow tonight. So just check the YouTube stream out right now.
Oh, what the? I didn't get the notification. Okay. I'm about to get on it.
Oh, that's why you didn't know. Okay. Okay.
Yeah.
Now, well, you know what? There was something really wrong tonight. Like my bit rate was 0 kilobits per second, and it just kept dropping the stream. So I started it like 4 times. Anyway.
There we go. No wonder why I couldn't get the question.
Yeah. Okay.
I'm on the video.
Awesome. Awesome. So, okay, sir. So here's the thing. These 8s are the same number. Okay, so for exponential functions, what that means is that we just bring down the exponents and set them in front of the 8s. Okay? And then the 8s just cancel out. And I'll wait for that to catch up on video. Yeah. So now I'm going to rewrite just the exponents because the 8s are gone. I'm going to write x squared equals 3x plus 10. And don't worry, I'm watching the stream, so I know how long it's taking. It'll be okay. It's like 10 seconds behind. Yeah. So now we're not dealing with an exponential function anymore. We are now dealing with a quadratic equation. So what I'm going to do is move, like we're trying to get this in standard. Now we're forgetting all about exponentials for now. And we're trying to get this in standard form where it's ax squared plus bx plus c equals 0. So I'm, yeah, now watch, I'm going to do this all in one step. And this, you're allowed to do this only when you get really comfortable with algebra. Multiple steps in one. And I think you're ready, Jonathan. And anyone else on the call, if you feel like you're comfortable with what I just did, good, do it. If you don't feel comfortable, then you can just move one thing at a time. But it just takes up more space. So I'm going to wait for the video to to show the full quadratic. X squared minus 3x minus 10 equals 0.
There we go. I wrote it down.
Okay. Yo. Right. Okay, so
Yeah, Kobe.
yeah, now, ladies and gentlemen, what we're going to do is factor this quadratic. So we're going to identify A equals, B equals, and C equals.
Oh yeah, how was your day, Mr. Morelli, by the way?
Oh, it was good, man. I got a bunch of stuff done, like chores type stuff. And now I'm just now getting around to the lesson planning. Yeah. I got to find a way to boost Jasmine's audio because I can barely. I mean, I can hear you. Don't worry. I just can barely hear you. Okay. Okay. So help me out, guys. What is A? 1. I heard that. What is B? What is B? I heard that. -3. What is C? -10. Good job. Was that Jasmine? All right. Good job. So now we're going to yep. We're going to analyze our information here. C is negative, so our factors will be different signs. And B is negative, so the largest factor will be negative. Okay? So what we're going to do now, ladies and gentlemen, is we're going to write our little table. Something plus something equals B, which is -3. And those same two numbers multiply to equal -10, ladies and gentlemen.
-5 and 2. -5 and 2.
Okay, so I know you figured it out, but let me just show how I would do it. So I would break this down into 1 times 10 and then 2 times 5, and I would list out 1, 10, 2, 5, and I would put the negative sign in front of the big number, and I would put the positive sign in front of the little number, and then I would add, and 1 plus -10 is -9, and 2 plus -5 is -3. So I know that I want to use 2 and -5 as my factors. So we'll come up here and put +2 minus 5 plus 2 minus 5. And since the leading coefficient was 1, that's all we have to do. Set this equal to 0. We have x plus 2 and x minus 5. And ladies and gentlemen, all we have to do now is set those two factors equal to 0 and solve for x twice. So x equals -2, and I'm going to let somebody else find the other solution. So I got one solution.
I already got it. I'm just gonna not say it.
Okay, you already got it. Okay. Does it rhyme? Does it rhyme with jive?
Yep.
Okay.
I already know. So yeah.
You already
that,
know.
so but
Okay.
I'm gonna listen to you and let somebody else answer.
Okay. I think I hear Jasmine saying something. Okay. Is this what you got, Jasmine? X equals 5 and x equals -2.
Excuse me. I just had barbecue chips.
Oh, okay. Oh, I saw Hilmer tonight. I was at the laundromat and he was there working.
Oh yeah.
He might be on this video right now. He said he watches these live streams. So hello to Hilmer if he's watching. He's a true OG. He really hooked me up tonight. Yeah. So let's see if we're right, guys. Here's what I think the answer is. I think the answer is -2, 5, like that. So it's two answers really. And so now I'm going to go check the solution. Okay. Now, this website that I'm on right now, this is a really cool website called Paul's Online Notes. This guy, Paul, was my professor in college. And when I took his class, I think it was like his first year of teaching or his second year of teaching. This was like 18 years ago. And anyway, he wrote this code. And so look at this. Here's our answer. We're right. So I'll try to show you guys this website. I mean, I do a lot of learning on this site. When I'm about to teach you guys something, I'll come to Paul's site and check what his notes are. So if you see there, we got the correct answers. -2 and 5.
Our x-intercepts.
That's correct. Okay, so I think we're ready to solve another one. So actually, exponentials are really easy. They're easier than quadratics, but we put them after quadratics. So let's go to the next problem, ladies and gentlemen. And here we go. I'll wait for it to catch up on the screen.
Alright, I made a line so that way I can separate this question from the next question.
Good. I'm going to do the same thing.
I did it vertical.
Okay. So now we have 7 raised to the power of 4 minus x equals 7 to the power of 4x. Okay. So this is question number 4. Okay. 7 raised to the power of 4 minus x equals 7 raised to the power of 4x. Now, here's a question once we get this loaded. Are the bases the same? Yes.
Bases, the numbers,
Yeah, I'm putting a yellow highlighter on what I'm calling the bases here in a second. You'll see it.
Oh, yeah, they're the same then. 7.
Yeah, they're the same. So when the bases are the same, they just cancel out and we bring down the exponents like this. So what we have is, yeah, you'll see it. Okay, so what we have is 4 minus x equals 4x. And can you guys help me once this gets written on the TV or the YouTube thing? Tell me how to solve it. I'm an old person, okay?
Yeah, it's alright.
Here, let me mute. I'm going to mute this. I'm going to mute this volume. And because I want to hear, I think, wait, there. Try talking now, Jasmine. Oh, that's way better. Okay. So I turned off the music and turned up the Discord volume on my headphones. So now I can hear everything. Okay, how do I solve this?
You gotta move the 4x left.
Yep.
Okay.
So I'll do minus 4x on both sides. Cancels out on the right. leaves behind a 0. And then I've got negative 4x minus x plus 4 on the left side. These are like terms, the negative 4x and the negative x. And I'm waiting for it to catch up on the screen.
There's no a because like there's not a square or
That's right. This is called a linear equation because the highest exponents are just 1. So help me simplify the left side of this equation.
what the Jasmine made. I got negative 5x minus 4.
Negative 5x minus 4?
Or negative 4, I mean. My bad. I think I.
So what we're really doing here, guys, is we're doing negative 4 minus 1 times x. And then there's a plus 4 that's hanging out here to the right. So what is negative 4 minus 1?
Oops. Oh, I gotta keep looking at the string. That'll be negative 5.
Mm-hmm.
Huh?
That's correct. So it's negative 5x plus 4 equals 0. And once that gets written, you tell me the next step to do. And then I'll show you guys one more problem, and then I'll call it off here because it's too late. Jasmine, what do I do next? Minus 4 on both sides. That is perfectly correct. Okay. So when we get to this next step, tell me what to do. The video is going to catch up in like 5 seconds. Or 10 seconds. Well, I'm just gonna end it. I have to end the stream because it's too late for students to be on a stream. So, but I do. Okay, I did. Oh yeah, Jonathan. So I made 2 videos this morning. I made one video where I got it wrong. And then I made another video where I got it right. And so I made the video that I got it wrong private. Yeah. So I think, whoa. That was weird. So I think x equals negative 4/5. You guys agree? Okay, let's see if we're correct. X equals 4/5. Is that what we got? Yeah, well, wait. X equals, I thought x equals negative 4. Let's go look at our work and see what we did wrong. Did we write the problem correctly? 4 minus x equals 4x. Yep. Then we subtracted 4x from both sides. And then we got negative 5x plus 4. Oh. We dropped the negative sign, guys. That's all. We dropped the negative sign. So it was negative 4 over negative 5. So x equals positive 4/5. Okay, so last problem, and then we will disconnect the live stream. I want you to see. We'll do this faster. I want you to see a problem where the bases are not the same, because most of the time the bases are not the same. Oh, perfect. Okay. So this is the last one. 2 raised to the power of 3x equals 10. So this is number 5. 2 raised to the power of 3x equals 10. Okay, and we should say 10 raised to the power of 1. Now, what you do in the situation where the bases are not the same is, I'll show you once it gets written, so you can see the problem that we have. We can't use our little trick where we just kill the bases off. That is a good observation. Okay, so here's how this works. And just watch for now, and then you'll understand later. Okay. So what we're going to do is we're going to bring down the exponents, and then we're going to do something called taking the natural logarithm of the base. And I'll show what I mean. So what this is 3x times the natural logarithm of 2 equals 1 times the natural logarithm of 10. Okay, so the inverse operation in an exponential is taking the natural log. And that is a brand new thing for you, but I want you to understand something. That taking the natural log of something is no more complex than dividing, multiplying, adding, and subtracting. It's just new. And so once you practice with it enough, you'll just think of it as just another thing. Okay, so these natural logs work just like variables. You can divide them, multiply them. Okay, you can't add or subtract them. So what we're going to do now is we are going to divide both sides by the natural log of 2, because I'm still just trying to solve for x. Even though we're starting to talk about natural logarithms, nothing changed about our goal. We're always trying to find x. And these natural logs work just like variables or numbers. If you have ln of 2 over ln of 2, it's the same thing over itself, so it just cancels out and becomes 1. Okay. And so you have 3x equals, and we can drop that 1 times thing and just say 3x equals ln of 10 over ln of 2. Now, well, hold on. So the ln of 10 divided by the ln of 2 is not the same thing as the ln of 5. These are actually numbers. Okay, so that that rule doesn't work like that. Okay, so now if I want to get rid of the 3 in front of the x, okay, what I can do is multiply the entire equation by 1/3. And then we would multiply that 1/3 to both sides of the equation. I'm going to let the video catch up so you'll just hear silence. Good night, Jason the man. Not sure who you are. Oh, Dustin. Good night, Dustin. Good night, D. Hope you guys did good at your competition. Okay, so we're ready. So it's got 1/3 times 3x is 3 over 3x equals, and now you're multiplying 1/3 times the ln of 10 over the ln of 2. So it's just 1 over 3 times the ln of 10 over the ln of 2. Okay. Oh, okay. So, all right, so he's still here. Yeah. Then I'm going to end it. Well, what I'm going to end is I'm going to end the Discord. So I'm going to keep the stream going. But I feel like it's not appropriate to be in communication with students after like this late at night. So I just, because I don't want them to take this away, because this is so cool. So what we'll do here is just, all right. So now all we're going to do is multiply 1 times ln of 10, which is just ln of 10. You can think of it like a variable. Okay, and then 3 times ln of 2 is just 3 ln 2. And this actually is a number. So what I want to show you guys is on the graphing calculator, I want to show what this number is. Okay, so on the graphing calculator, you would, and I'm going to wait for that to pop up so you can see it. And you have to use a graphing calculator typically because these numbers are weird. Okay, they're not easy to find by hand. In fact, there is a way to find it by hand, but you won't learn how to find it until Calculus 3, which you would take in your junior year of college if you were studying math. Yeah. So for now, we just use the calculator, and you don't have to feel bad about using the calculator for these logarithms. Oh, now it's buffering. That's great. Yeah. Well, actually, it's my side. I have no idea what's going on, but well, no, the bitrate is good. It should catch up. It's 2,700 kilobits per second. That's plenty. Wait, are you guys seeing a buffering? It's when there's a little circle, rotating circle. You see that? Okay. Hmm.
I mean, I had to like play the video for the stream, like, 'cause, like, for some reason,
Well, I don't know if we're gonna get anywhere here. Let me check the stream health. If not, I'll just tell you guys what the number is, and then I'll tell you if we're right or wrong. Okay, so well, sort of like that is what we were going to start next. Yeah, the stream is not working well. Okay, so are you looking at the calculator right now? Oh, great. Okay, so all right, it was just on my phone. Okay, so alpha y equals enter. All right, nothing strange there. And what we're going to put in is ln of 10 over 3 ln of 2. So you find the ln key down here to the left of the 4. You see that? You've probably never pressed that key before, right? ln of 10, and then you close those parentheses, over 3 ln, what was it, 4? 3 ln of 2, sorry. Okay, so once you get in the calculator looking just like it did on paper, we'll evaluate it. And I just want you to see. Yep, I see it catching up on the calculator. And then I write 4 incorrectly, and then I back up and change it to a 2. Okay, ready? We're going to hit enter. 1, 2, 3. Very interesting. You'll see what I mean by there's no way to do it without a calculator when you see this number.
I can't use the calculator, otherwise I have to get off YouTube app.
Oh, right. Okay, see that 1.107? 309? Yeah. So it's not a, it's a, what do you call these types of numbers? Irrational, right? Okay, so it's an irrational number. That's right. So now we're going to show all steps and see if we're correct. Hey, how about that? And one interesting thing that when you see Paul's notes is we learned a rule, and that's a rule we'll have to remember. Oh, see, Jasmine's stream is ahead of mine. See, on my stream, I still can't see the answer. There it is. Okay. Yeah, you see the answer. Now, notice this. Notice that it says 1 over 3. Okay. So what I'm going to do is just go back to my OneNote and just write one little tidbit to remember. See if you can just put this in your memory bank. The natural log of 10 is 1. So that's another little trick. Now, if you don't remember that, you can just write in ln of 10 and the calculator will do it. But knowing that ln of 10 equals 1 can save you a little bit of time. Okay. And it looks prettier. So on that, yeah, and I know, yeah, Jasmine appreciates the aesthetics of the math. So, guys, at this time, just to be in compliance and everything with school policy, I'm going to drop the Discord down, but I'll keep live stream running because I'm going to continue lesson planning. All right. Okay. Good night, everybody. Bye bye. Thank you so much for joining this Discord, and we will now leave the call. Okay, so I'm still here on voice. But I'm basically having a Discord with myself since I feel like, it's probably not a good idea to run that late. Next time we do this, when we get on future Discords, we'll just start it earlier. Sometime like 6 to 8 would be great. Once we're past 8 o'clock, it starts to get a little sketchy with district policy. So, I'm sure it's fine. It's just I want to maintain compliance because I would hate to have them take away our ability to do this. So, okay. So one of the key concepts with exponentials is their graphs. And the thing about the graphs is that exponential functions have something called an asymptote. Okay, so everybody gets to say a bad word when we're talking about exponential functions because the way you pronounce this word here is asymptote. Asymptote. So, I mean, I don't want to write it out because if I write it out the way it sounds, it's going to be a bad word. But that's how you pronounce it, asymptote. It's not the P is silent. So it's like asymptote. And it says here, an asymptote is a line that a graph approaches. Okay, so over here, we see an asymptote. Okay. We'll identify those asymptotes later. Yeah, the key thing about exponentials is that x is in the exponent section. So let's look at these two graphs here just so you know what an asymptote is. An asymptote is a line that the graph approaches. And it means that it will never go below this line. So right here, I see an asymptote right here. Okay. So the graph never goes below that line. It approaches it, but never goes below it. Now, what confuses students is they think that this vertical line is an asymptote. But check this out. If that was true, then this line, you're saying this blue line would never cross that other blue line, but it will, right? It's going to cross it. But this blue line here going down here, it's never going to go below the red line. Okay. So, here's another asymptote. And there will definitely be one of these on the STAR test. So you've got to know this. Here we have an asymptote, and I'll do this one in red. Okay, here's the asymptote. And typically it's represented in the STAR test like this. It's a dotted line. It's not always horizontal. Okay, it's not always horizontal, ladies and gentlemen. But let me tell you, this vertical line, which I'll do in green, that is not an asymptote. But you will be given the option to choose it as an asymptote because they're trying to confuse you, right? But all you have to do is say in your head, if I were to continue drawing this line, right, it would definitely cross the green line. But if I'm looking here at the red dotted line, then I can see that blue line is going to just get infinitely close to, but never below, ever, the red dotted horizontal line. So that means that this red dotted horizontal line at y equals 0 is an asymptote. Okay. So we've actually covered quite a lot today. Looking here at exponential growth functions and exponential decay functions, the domain and range are very importante. So it says that the domain is all real numbers. Okay. The domain is all real numbers. And the range is all values greater than the asymptote. Okay. So it says it's greater than 0 for this one. But what if your asymptote is not 0? So the range y is all values greater than whatever the asymptote y value is. In both of these cases, it's 0. But if it was not 0, then you'd have to look at it. Now, the domain is all real numbers. Okay, that's this symbol. All real numbers. Over here, all real numbers. But notice the range is the one that's going to get you on the STAR test. So for quadratics and exponentials, the domain is all real numbers. But the range has a low or a high point. Okay, it's either got a top or a bottom. And then depending on whether it's a top or a bottom, the rest of it is all real numbers. Okay? A cuss word, why math? Yes. Okay. I am now going to show you guys the next page from the textbook, and then I'm going to take a little break. What I'm actually going to do, you know what I'm going to do instead of the textbook? I'm going to put up the next question from my professor's notes page. And for me, it's so cool to be showing you my professor's notes. So you guys see if you can solve that. All right. Use your graphing calculators to approximate the natural logarithms. And I'll be back. Okay, so let's get back to the problem here. Seven to the 1 minus x equals 4 to the power of 3x plus 1. We'll solve this guy here in OneNote. Okay. So we're going to solve this now. Huh. It's not pulling that audio. Oh, it's disabled. Now we'll re-enable it. Hmm. I don't know why it's not sending the audio. You guys should be able to hear the audio. Hang on a second. I'm going to kill OBS and then turn it back on. It'll come back up. So all right, so what we're going to do is we are going to take 1 minus x. Okay, so we take whatever's in the exponent section and we bring it down in front, and then we take the natural logarithm of the base. Okay, so what that turns into is 1 minus x times the natural log of 7 equals, same thing here, bring this guy down, and then take the natural log of 4. Okay, so we'll bring down 3x plus 1 times the natural log of 4. Okay, so to get these things together, this is a really interesting problem. Because what we're going to do is we are going to divide this entire equation by the ln of 7 times 3x plus 1. And when we do that, what we'll end up with on the left side is 1 minus x over 3x plus 1 equals the natural logarithm of 4 over the natural logarithm of 7. So the question is, how do we get x by itself in this situation? Okay, so here's the first step. And here's the second step. And then here's the third step. Oh, I see what they wanted us to do. I was making my life too hard. We distribute, multiply, and then combine like terms. Very interesting. So I wonder if what I did was wrong, because what I did was mathematically correct. So I wonder if I can get to there. How'd they do that? Okay. I think there's actually a way I can do this. Do something here real quick. I want to check something before I just do their way. No, those are only for complex numbers. It doesn't work like that. Okay. So I see what they wanted us to do was distribute, multiply the ln into each term inside the parentheses. Okay, so what they wanted us to do was 1 times ln of 7 minus, minus 7 times the ln, minus x times the ln of 7. And that equals 3x times the ln of 4 times the ln of 4. Or times 1 times the ln of 4. Plus 1 times the ln of 4. Okay, so this looks kind of messy right now. But I'm starting to see some stuff here. Oh, okay, so here's what they want us to do. They want us to group these two terms together. And they want us to group these two terms together. All right. So I guess that would be plus x ln 7 and plus x ln of 7. And over here, we would have minus ln of 4 and minus ln of 4. Okay, so these cancel and these cancel. All right, so now we have ln of 7 minus ln of 4 equals 4x ln of 7. All right. And now all we have to do is divide the entire equation by 4 ln of 7. Okay, I got it now. So, oh wait, there was something we were supposed to factor out an x. Oh, I bet I wasn't allowed to do that. I made a mistake. So remember, you can't mix those ln's. Gotcha. All right, so mistake to call these common terms. Gotcha. So this is just 3x ln of 4 plus x ln of 7. And now what they want us to do is they want us to factor out the x from this expression on the right. Okay, so we have ln of 7 minus ln of 4 equals x, open parentheses, 3 ln of 4 plus ln of 7. Got it. And that's what they want us to divide everything by. So we're going to divide both sides by 3 ln of 4 plus ln of 7. Got it. And then these cancel out. So what we have here is x equals this whole thing. So what I want to do is evaluate that in the calculator. I wonder if my ink to math will work. Okay. A lot of math, yeah. Let's see if this works. I wonder if it'll work. Oh, it's kind of jacked up. No, that didn't work very well. So we'll put it in the TI. Okay. Okay, so what I'm going to do is put this whole thing, alpha y equals enter, and I'll hit ln 7 minus ln 4 over 3 ln 4 plus ln 7. 0.0916. Okay, so let's see if that's the correct answer. Whoa, did you see that? Oh, I just learned something cool about this tool. Check this out. So I'm going to put my finger on this answer and pull it directly into OneNote. Wow. That is super cool. I did not know I could do that. That is super, super cool. Wow. Okay, I'm impressed. So let's see if Paul's answer, we're all going to have to write letters to Paul. Okay. Let's see if that's the answer to the question. So I think the answer is 0.0916682624. Let's go check it. Oh, yeah. Awesome. 0.0916682662. And then our calculator just took it farther. That was a tough problem. Wow. So, let me copy this because I want to put this in OneNote. So here's a link to Paul's notes on exponential functions. Okay. We'll make this bigger. Whoa, that's way too big. Here's his practice problems section. Yeah, these are great problems. Kind of want to see if he's getting these from it, what textbook he's using to getting these from. Chapter 6 of what? What book? Oh, they're all his. Hmm. Oh, wow, we can download it? Oh, wow. We can download the complete book. Oh, this is great. Okay. Okay, it's 10 o'clock, so I'm going to end it here. Thanks for watching, guys, and everybody get some good sleep. What we're going to do tomorrow is review for the test. And then on Tuesday, we'll have a test. Okay, so. It's weird. Okay. Later, everybody.